Kevin and I are checking out the Dell PowerEdge R770, which is on this table somewhere. What have you done here?
Yeah, so I have a lot of the servers set up, and I want to show the progression of how Dell's improved things over the years, starting with the 740, 750, 760, up to the brand new 770.
So we've got like 8 years of Dell servers. I think that's about 8/10 of a decade. Where is the 730? Because that's the one we needed to really pull together a decade of PowerEdge.
I couldn't fit it on the table, and we gave them all away.
Okay, so we gave away the 730. I'm surprised we still have 740s, but in the day and age of us thinking about needing the latest CPUs and GPUs and everything, the 740 still holds its own, even though it's 7 years plus at this
Well, yeah, I mean, this
time.
was the first one with NVMe support. 730 was kind of still in the era where it was PCI accelerators and things like that.
The edge cards for your SSD goodness, SATA, SAS, those sorts of things.
Remember the R720, the Express Flash slots?
Yes. That was trippy. And at the time, those were amazing. Today, less so, but that's why we have this progression of technology before us. So part of the reason why we wanted to get all 4 of these out was to better illustrate change over time with the PowerEdge portfolio, from little tiny things, literally, like front adapters for USB, to really big changes they've made as we come down to the 770, like OCP compliant slots throughout the whole thing. Where do you want to start with this breakdown?
I think with 740. This model, so all these models you can still configure with SATA and SAS 2.5-inch drives, although it starts to get a little bit skewed with the 760 and 770, where if you want Gen 5 support, you have to go to a E3.S form factor, which still like 2.5-inch drive, a little bit thinner, depending on the model.
We have them sitting here.
Yes, we have a lot of those.
For size comparison, we've got a couple drives just sitting in the stack here. This is the E3.S. This is a 7.5 millimeter Z height compared to a 15 mil U.2. Half the width, a little bit thicker on the on that side. These guys will go up to about 60 terabytes now, I think, and in the U.2 form factor, we're at 122.
Yeah, there's a big part with tri-mode on the U.2 connector. It gets a little bit sketchy for Gen 5, and there's much better signal integrity on the EDSFF connector.
Right, which is why this connector is all the rage. But as you found out recently, when you ship these things, you have to be a little more careful if somebody throws away all the little plastic cases they come in.
Yes, it's a little fragile dude sticking out in front, and it'd be very sad if it got broken off in the mail.
It would be sad. Okay, but I said, what do you want to start with? And you immediately jumped into storage. But I know there's some little fundamental things you wanted to highlight between the platforms.
Yeah, so in this configuration that we have laid out, the R740 can be configured with 8 NVMe bays. The model here is just SATA and SAS, but even there, you still get to see some of the improvements that Dell's made. So,
wait, that one probably came with hard drives too, still.
Yes.
As an option. Is there a 3.5-inch or a 2.5-inch hard drive backplane for this server? Please say the answer is no. No.
It still supports SATA and SAS, so yeah, probably 10K is an option.
Great. I hope not. No, don't do that, people. Why would you? Anyway, carry on.
So cabling changed a lot between these models. You had wrap SATA and SAS cables, got a little bit thinner, a little bit better on the R750. R760, you start seeing designs where it's like, hey, the size of the cable starts to make an impact to airflow, and you see optimizations. Then you go to the 770, and cables got smaller, cables got a little more round. You have a ton of NVMe cabling for a backplane that can support 32 or 40 NVMe drives.
Well, speaking of cabling, I know it's not necessarily specific, and it's hard to tell when you look at these platforms, but with the PowerEdge platforms, the cable length has always been a precision element across the whole family. In terms of the one that goes from this port to this spot on the motherboard, the lengths have been dead nuts on every time with very little slack or extra stuff.
Yeah, we've run into that where I think, okay, this is the R750. We actually had a problem where one cable, we ended up having to swap it out. And we had to have the exact cable for between like 2 ports because, I mean, you're at a range where the cables are most often pre-bent, but like a centimeter shorter or longer makes a big difference. And you don't want extra cabling just willy-nilly in the front because you're going to block airflow for things downstream.
It seems like such a small thing, but that's one thing you pay for when you go to a premium server are the design elements like that, Whereas on some other servers that aren't quite as well thought out or as well designed, we'll get like a big nest of cables that gets just chunked over to the side of a system. And while most of the time it won't make any difference, if you're really trying to push this thing, especially with GPUs, that will be a problem when it comes to airflow.
Yeah, and one thing that is pretty cool that we didn't see on the early models that started present on the R750, the RAID cards move from the back of the server up to the front of the server. So you end up having a design where instead of having cabling, in your case, going from front to the back of the chassis, which in the R740, we have cabling going from the front, snaking around the side, going to a RAID card in the back. You could still do that, but why? In this case, the RAID card gets mounted directly to the backplane itself, and it's up and out of the way. And you see that even in designs with SATA-SAS or NVMe.
So it's interesting though, as you talk about cables, one other thing that stands out to me, you move the RAID cards to the front. If you're using a RAID card, you don't have to. We'll talk about that. But just the PCB behind the backplane, or that's part of the backplane on these three, and you look at this EDSFF one, and there's so much more vacant space up here. Granted, we only have 2 of the banks filled, but there's that whole top half, there's nothing at all there obstructing. We'll
show in a different view, but the traditional backplanes that we found on the 2.5-inch form factor for SATA-SAS, or even on the U.2 NVMe side, the airflow from the front to the back all comes through a single small slot. And if you're worried about how to cool your next-gen GPUs,
gosh, or even your NICs at this point, those dudes are getting so fast and warm as well.
Well, yeah, I mean, that little bit of airflow has to handle the output of the drives, the CPUs, the DRAM, and then the power supplies and the GPUs in the back. And right now, you look at some of the latest platforms, the GPUs might be the most power-hungry devices inside that server, and they're at the very back end. So when you look at how they can handle the new SSDs are connected, a lot of space is open up for less impeded airflow.
And we didn't say, but it should be worth noting that Kevin's yanked out all the parts of these systems to make it more clear so that we can see the motherboards really well. But typically you'd have risers across the back, you'd have a fan bank in the front, and maybe some more shrouding. We've pulled all that away, so lest you think these are some sort of fanless PowerEdge designs. They are not.
No.
But you would have your fans sitting in the front of each one of these, and airflow is a big deal, and it's getting increasingly bigger of a deal because fans have gotten better, but they've not gotten a lot better over the generations.
Yeah, and
the heat's only gotten worse in these things.
Well, and a lot of these platforms, the later generations support DLC cooling, so if you want to do liquid cooling for the CPUs,
which we did in the 760.
Yeah, it's very minimal in the amount of work that's needed, and it's the same thing for the 770. The fans take up a large component of power in a lot of air-cooled systems. So you're looking at 30% of power just from running the fans themselves.
Up to 30%, depends on what you're doing, and it depends on whose numbers, but at least 15 up to 30 is, I think, commonly accepted at this point.
Yeah.
So you talked about airflow, and I want to come back to that when we look at some of the heat sinks and stuff, but one thing that I led with was the USB differences in the front, and that's a minor thing, I guess, in my world, because I don't administer that many of these servers, but you do, and talk about the very front access panels of these things.
We have USB across the board, although there's fewer ports on the R770. It's gone down just gone down to one USB-A port, which I'd still say it's the most common device to do like a Windows or Linux install, that sort of thing.
Yes, but USB-C is sort of the thing now, right?
Yeah, so you still maybe want that. You want to have your larger data sets on a USB external hard drive, for example. But the big change as you look at the front is on the 740, 750, and 760 of VGA still. On the front of the 770, it's just a mini DisplayPort connection.
So that might be a little modern for IT admins.
So yeah, there's still VGA on the back, but the size of ports are making a big deal on systems. You don't want additional ports that you maybe don't need on systems, and a lot of people are leveraging iDRAC, which is fantastic, instead of having to do front monitor access. But yes, you have a different port to deal with now.
And we don't have the bezels on the front, but the bezels for these three all look the same, changing the Dell EMC, Dell branding over the years. The one thing that these honeycomb ones had, though, as an option was that little display, which got sent out to the farm
I
to live out its life. But
yes, that display was fantastic. I didn't use it for much, but you could change the static IP. So
Right.
when we normally get systems in, they might be pre-configured for another data center. And from like the 3 buttons on the front, you could change it from a static to a DHCP address.
Yes.
And all of a sudden, you could change the IP address for iDRAC from the.
So we didn't have many of those. I think we had 1 or 2. So Kevin would use the same bezel on every Dell system, every 2U Dell system that would come in.
But they're the old ones.
Yeah. And now the new one picks up a different honeycomb design. Where is it?
It's right next to by your right arm.
Goes with this bezel design. It's simple. It's probably costs half of,
Look how much airflow that has.
30% of the one that had the little display in it. So for those that run bezels, this is what it's going to look like now.
Oh yeah, and yes. Well, actually, yes. This is the more current one.
Yeah.
But yeah, I mean, it's thinner. It weighs less material, and I think there's probably a little more airflow through that.
All right, maybe so. Anyway, had to do a minute on the bezels.
Yeah. So to start off, the heat sinks on the 740 and 750, they are taller. You can get taller heat sinks on the 760 and 770. These systems are both set up with GPUs in mind.
Right.
So they're flatter because the GPU ends up sticking and kind of overhanging part of the DRAM and CPU, so they have to be shorter. On here, I mean, you'd probably have to take like a trimmer and chop that out, but they do offer a low profile heatsink for it.
Buy the right one and don't sawzall it would be my suggestion if you're doing this at home.
Yes, but there has been a significant change in the density capabilities of the heatsinks because CPUs being more and more powerful, and you have to be able to handle that wattage going through the front of the chassis.
Well, and that's why the direct-to-chip cooling is so popular. We've got the Cool IT rig. We've done a lot of work with the R760. We converted this one, but you can order it with the cold plates already pre-installed, tubes out the back, and you're ready to go. We'll dive into the direct liquid cooling changes on the 770 in a little bit and talk a little bit more about that. And of course, Dell partners will do these in a variety of different cold plates and immersion and anything else you could possibly want if you want something less standard than an air-cooled version of any of these servers. So Vince probably put the table spinning in just to troll us in the video, but we have spun the table around now so that the 770 is now on that side, 740 on this side, and the others in their remaining positions. But this is so you can get a better shot of what the airflow looks like as we come through the back of the system.
Yeah, and there are some interesting components into the layout. I mean, you have the...
Well, this is the biggest one, right?
Well, yeah, you look at that the back of that chassis, it's kind of surprising where on these, they're really open in the back because all of the bays are modular risers. You can remove everything and you can change the configurations pretty well. The R740 was a little bit more rigid in terms of what it could support and how it's configured. And in that, that just looks old compared to what we're used to seeing.
It looks old, and it also has the power supplies together. So the jump from the 740 to the 750, as they split the power supplies and got a little bit more intelligent about the cooling profiles in these systems, that's where this picked up and then continued to improve on intelligent fans and negative pressure zones and things like that.
The original R740 motherboard, it's longer than what you'll find in the newer systems, and a lot of that comes down to...
Not by much though, eh?
Well, a lot, because you go from the same starting point to the rear of the chassis. These guys all have spots for little OCP cards.
All right, fair point. Okay.
A lot of it comes down to signal integrity, but also you want more serviceability. There are some components that now are, that used to be on board that are now replaceable. So in the R740, if you had a iDRAC failure, for example, the entire motherboard is the component you have to replace.
Right, because that iDRAC silicon was on the board.
Yeah, so
right.
On the 750, 760, and 770, these are all replaceable cards now, and we've actually swapped out the iDRAC card on the 760 builds as part of the DLC swap because there's a little added connector for the where the liquid loop plugs in for its like leak detection, and that part ends up being replaced, and that part can be replaced, so if something breaks, it's a field serviceable component.
Right, well, better to lose a card that's easy to swap in seconds versus the motherboard, which is tedious, which we've done before, not on a PowerEdge, we've done it on another server, and it's such a drag to take all the stuff out.
Yeah, and we've removed So one part that you can't see, although maybe I will grab a riser that has it.
Give you a little dance.
Oh! This is a riser for a 750. I know it because I wrote it on the top. So the part that's interesting is when you look at the back of the R770, the BOSS card is now in the OCP form factor.
And that's interesting, and we'll spend some more time on that.
Yeah, the R750, R760, it became a replaceable component. On the R740, it was a little card that kind of was inside the system, so you couldn't replace it or swap components as easily. It became a hot swap component in the later servers. But
wait, remind me, did the 740 have SD card boot and SATA DOM and that kind of stuff too back in the day?
Oh yeah.
Yeah.
Micro SD cards.
This was the pinnacle of server boot for some period of time.
You go from not hot swappable to a hot swappable external component,
right,
to something that is cabled on the R750 and R760 to something that's a onboard slot connection with OCP form factor.
That we've progressed, over time from micro SD to NVMe in that time span as well. Not that you need a high performance drive, but the fact that that's just where drives are being made. It's very hard to find an enterprise SATA M.2 drive. It's not impossible, but there aren't a lot out there. We've dropped off the two older systems. We really focus in now more on the R770. And if you're still with us in this video, that means that you like this nerdy stuff, because we haven't talked about any performance yet or what we did with GPUs or any of that stuff. For now, we're going to keep that all in the review that's on storagereview.com. So if you want to know how well this thing performs, just read the review. We don't have time to get all of that into this video. I don't even know where we are on our timeline, but this is probably going to end up being 30 minutes of super nerdy stuff about PowerEdge, so performance we'll leave alone on that. Like we said though, this system adopts a ton of OCP goodness. If we look back and why this 740 looks old, as you said,
yeah,
a lot of that's because so much proprietary tech in there that was not necessarily modular or open standards or anything of that nature.
It was the early days where most network connectivity was either onboard or it was an edge card, and there wasn't really the concept of the little swappable guys. HP had their own interface, Dell had their interface.
So one of the most exciting things about the R770 is the move towards OCP adoption, and we'll talk through all of what that means. And when we looked at the R740, for instance, and why it felt old to you, it's because a lot of that was proprietary design and adopted none of OCP. And as the systems progressed, we saw OCP get picked up mostly in the NIC slot, and now much, much more, of which we'll show you.
Well, yeah, those early systems didn't really have onboard connectivity in terms of fast networking. You had either 1 gig, I think maybe 10 gig was just starting to become onboard.
Right.
But if you wanted faster connectivity, this was Dell's interconnectivity card for the R740 platform. This is a quad port device. This guy had 2 1 gig, 2 10 gig. We actually swapped a lot of these out for the dual port 25 gig Mellanox, now NVIDIA cards. But it gave you an option to get faster networking kind of on board without consuming a PCI slot.
Talking about the NIC slot, and we'll take all this apart and show you, but the R770 is, OCP was an MHS compliant, fully compliant.
A lot of the OCP standards make it easier to iterate on servers, make more broad acceptance between different platforms, and maybe bring down costs a little bit, but a lot of it makes the things easier, so you don't have vendors trying to make one specific part just for Dell, one for HP.
Right.
You have more compatibility across the market.
Well, for everyone, and when you look at OCP, their event is in the fall every year. It's a great show that's mostly driven by hyperscalers, and the hyperscalers needed uniformity across the platforms. That's why this stuff exists. It's really exciting to see Dell increase their participation in OCP. They actually were there last year in a bigger way than I've ever seen, showing off things like this type of compatibility, but also their 21-inch server designs with busbar power, the liquid cooling designs. There's 2 really great liquid cooling specs being developed at OCP, one for direct-to-chip and one for immersion. That's all coming, and Dell is being involved in all of those, which is why we see a design like this. So OCP 3 NIC slot, pretty standard, but still worth calling out as a nice design element in the 770.
Definitely. And you'll see on the back of this, depending on how many PCI lanes you want to allocate to that slot, you do have additional PCI connectivity there. I believe the way this guy's set up, it's 8 lanes currently, and you can connect additional lanes into that if you want it there. But a lot of the platforms are set up where you can have different number of lanes going to individual slots depending on, do you want those PCI lanes going to risers, do you want going to front bays? There's a lot of different ways to spread around the PCI connectivity.
Lanes are something we'll talk about over and over and over again, whether it's the 2 Intel system that we've got here in the 770, or when we look at the AMD systems with all the extra lanes available in there, the allocations between storage and GPUs and I/O modules, it becomes a big challenge. So moving on to the Boss card, that's another thing that you talked about. Twin NVMe drives on board. The drives themselves are hot swappable, if I can wiggle my fingers back there.
You can still take them out the same way that you could on the previous models, although now the entire card is a easier to swap component. Before, it was kind of built into a riser.
Right, well, the connector here is EDSFF. So again, getting to standards that make it easier. It's not as if there's going to be a lot of third-party versions of this card, but again, it makes it simpler from a design standpoint. And if they're going to run 8 or 16 or 40 of these connectors up front, it's probably similar part design, similar signal integrity issues that they have to deal with back here, which hopefully makes the whole system a little bit easier to manage and more reliable potentially. As we continue to progress down the connections here, this guy is what we all knowingly and lovingly refer to as the iDRAC card, but it's a little more than that in the OCP parlance.
Yes, this is the DCSEM, or the Secure Control Module, and this guy is iDRAC functionality on the R770, and it's replaceable, and you also have a little cable that goes to the front. That's so there's USB access going directly to the outband management,
right,
versus the USB-C connection, which goes to the motherboard itself.
All right, let's go ahead and slide that guy out. It kind of looks like an OCP3 NIC. It's not, it's a different spec. And this is one thing that OCP has been working on, I know, because there aren't that many, if you're not Dell, for instance, or HP with ILO, there aren't that many third-party out-of-band management secure cards. And that's something that OCP is trying to make more standardized, that there could be some other options outside of just A-speed in that regard.
So you have iDRAC on the traditional PowerEdge platforms, as well as open manage offerings on their hyperscale systems.
Right, and what we can't underscore though is the capabilities of what iDRAC can do. This little card that Kevin's holding is one of the things that makes a PowerEdge, in my opinion.
Yeah, it is probably the best management platform we've seen, bar none, across the entire industry. You have the capabilities to run out-of-band management protocols, so the traditional things of, hey, the system's off, I'm going to power it back on, but what if you want to look at the power details of what your GPU is drawing? You have that functionality that's brought in on the newer systems. You have the ability to do out-of-band configuration options, so you can change the entire setup of your server options-wise, or think if you're deploying 10 of these systems or 100 systems at a time, push your profile onto all the systems to do BIOS optimizations, things like that. You don't have all that same functionality on other systems, or you can't do that through the same kind of nice GUI interface that you have on the iDRAC
Well,
side.
yeah, the GUI is the nice thing. I mean, from my perspective, I don't do this a lot. You do this much more than I do. But the ability to just sort of click, 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 upgrade, firmware, whatever you want to do, makes it really simple.
Oh yeah, and there's a lot of things we can do with here. Just the firmware aspect, I can push firmware to most of the devices inside the Dell chassis through the iDRAC interface. You can't do that on all systems.
Right, and so that's a big advantage. Again, with a modular design, OCP compliant on that card as well. Now, if you thought we've been nerdy, possibly too nerdy so far, it's about to get real. So starting with the risers, we've got a couple connectors here. These are the MXIO spec. Talk a little bit about the options as we build the risers out.
So on the risers, we have rigid standoffs. We also have the cabled standoffs.
Right, we've got another one here for the GPU, right?
Yeah, signal integrity is a huge deal for PCI Gen 5. So you'll see more attention to detail on how cabling is handled. Signal integrity is a big deal, as well as airflow, and one area that you start seeing on the lower standoffs, if they're not populated, they're filled with blanks. So you don't want cold air being passed through a device that's not utilized.
We don't always see this level of efficiency, and actually, if you didn't use these ports in the back, they would have blanks too, right?
Correct.
And again, we see it in the risers. Another place that we would typically see those little airflow items would be in the DRAM.
Yes, this was
as well.
fully populated with RAM, but
The 760 took them out mostly out of the 760. But if we were operating as a normal, sane entity would, if there was a blank space here, there would be another a little plastic thing to keep the airflow going.
So on all the PowerEdge platforms, the shroud is one of the most significant areas of how air is kind of pushed through the chassis.
Right.
And as you can see, there's pass-throughs for the GPU airflow in this configuration. It varies a little bit depending on the overall makeup of the risers, but you're going to have, let's see, this guy is
Upside down, this
yes. So this one kind of would sit right there.
Right.
And you have airflow that goes from the fans directly into the GPU.
And for these enterprise GPUs, that's important because they're passive, right? They don't have fans on board.
Correct.
The riser selection is important here too, because we can fit 2 full-size GPUs in this system, but you've got to order it that way.
Well, yeah, because so you might have seen the larger heatsinks on the R750 or the R740, but these low-profile heatsinks, they have certain compromises. You can't put higher TDP CPU configurations with a smaller profile heatsink, and then
Right.
there's also fan considerations as well.
Right.
So if you're trying to reconfigure this after the fact, you might have different fans, different heat sinks, different cooling structures. You're going to have a lot of different...
And power cables, right? Because we found as we tried to add GPUs to this system that there's a left angle GPU,
Yes.
there's a right angle GPU, and that goes back to Dell specifically designing every single part for the use case. The R770 is infinitely flexible, but the more you know about your workloads ahead of time, the better off you'll be in being happy with that system design.
Correct.
So we've added the NIC, iDRAC, and BOSS back in, and now to just kind of show our riser configuration, I think it's easier if we visualize it, and Kevin's dropping that in. Just like other PowerEdges, the blue means what?
The blue is, I think, a touch element, so it's user serviceable.
Right. Before we put the top risers into place, because they're going to start to hide some of the other things here, we've got to talk about the power supplies. They get up to a pretty beefy size now, but they're actually skinnier than what we saw in the 760 and the older units.
Yeah, the way power supplies are handled, before you were looking at the biggest power supplies you could put right on the system. Now it's a how to get the smallest physical footprint inside your chassis without compromising the power delivery.
Right.
The way GPUs are given power from the chassis has kind of changed over the years. So we have, going back to, I think this might have been the R740, you had a very rudimentary power delivery method. You had...
That's what you would see in a gaming rig or a workstation. Something
Yeah.
similar, right? Just a dumb cable.
Yeah, basically a industry standard connection and just power lines. So on the R760 though, you start getting some logic in the cable because
An embedded microchip in the cable.
Yeah, you want current sensing capabilities. You want to find out how much power your GPU is drawing because that might change what your air profile is.
Incidentally, they do this with the DPUs as well. They've got a logic board in line.
And for the R760, they were on a proprietary but still pretty capable connection for connecting to the motherboard. And you went from like a 2-blade gold-plated connection to a 12-volt PIC PWR connector, which looks quite similar to what you'd find on a lot of the emerging current generation NVIDIA GPUs. Mm-hmm. And this guy is on the server platform is capable of doing, I think it's 867 watts of power. Now, from what we've seen, that tops out more realistically at 675, so 75 watts power out of the riser, 600 watts over the cable. But you're talking about a substantial amount of power, and that's where you get into, you want the cable designed exactly, even from like left and right in the chassis.
So the power supplies themselves also adhere to a standard, the MCRPS, right?
Yeah, and that's size, and that's even things like the LED lights on the back for status and things like that.
Right, and so I think in combination then, this makes the R770 the most open platform Dell's ever produced.
Yeah, definitely. It's pretty fun to realize that you could probably mix and match components from other servers and build like a different iteration of a PowerEdge.
Let's maybe not do that,
Yeah,
because
it may not work. Hopefully it doesn't work. We'll find out.
No, we're not going to find out because we're not going to do that. It might work. So as you put this thing back together, I know you were working on the other risers and the airflow bits. The storage is the other thing that, as we think about lanes and power, becomes really important. Our configuration is 16 drives direct attached. So talk about what that means from a storage perspective.
So we have 16 drives in this configuration. I think they'll top out at like 220 or so gigabytes per second with 16 drives.
It's 16 by 4, to be clear, of Gen 5.
Yeah, and Dell's taken a little bit of a different approach on their newer servers with E3S. On the past systems, when you went from 8 to 16, I think it was from 16 to 24, a PCI switch was introduced.
Right. This
and
is
you kind of see it a little bit there. It's really done because there's only so many PCI lanes to go around, although a switch does introduce other problems. In this
more complexity.
Wait, in this system, I think we're able to get higher performance from 8 drives direct attached than 24 drives through a switch just with the lane allocation. On this side, what Dell's done is if you want to go from 16 to 32 drives,
right.
It's still Gen 5, it's still direct attached, but you go from 4 lanes down to 2 lanes.
Right, and it just depends on what you want. If you want the Gen 5 storage performance in a smaller capacity drive, if you want the 122 terabyte capacity in a Gen 4 U.2 drive, and then these guys even come in capacities up to 60 terabytes. So there's all sorts of choices when it comes into the storage backplane, but it's not just direct attach. They do RAID cards as well with this, as we noted early on.
Well, yeah, so similar to the previous generation models, the per card, PERC 12 and then 13, which will obviously be coming down the road,
right.
They're mounting this mid-plane area instead of in the back of the chassis, so you minimize cabling changes, and then you're leveraging the same PCI lane connections
right.
that normally go to the drives themselves to go directly into the PERC cards, and then the PERC card would go to the drives. But it's a very simple layout that minimizes airflow disruption.
And PERC 13, as Kevin noted, will be coming for Gen 5 drives. That brings a whole another host of benefits for RAID-protected storage. But there's another option still if we want to use a little bit of GPU as a RAID management device with the Grade product, which we've used 100 times at this point, for a more performance-heavy RAID design.
Yeah, and those might be in areas where, say you're running a GPU-heavy workload, you have some H100s in play. You're talking about using like 6 CUDA cores for the Grade?
It's less than one. It's like 0.8% of an H100.
Yeah.
If you want to use the Grade algorithm, and that takes the whole RAID management, takes it off of the CPU, much more efficient than, say, software-based RAID, which gives you much more performance with Grade than really anything else. And so the 770 just really highlights so much flexibility in design. I know as you're putting these back together, we've got the GPU in this one. We can put another GPU in that riser, as we've noted. This will support 2 double-width GPUs in this platform. You can also put a bunch of little L4 guys in here if that was your game. We've got, the L40S in this guy, right?
Yep, and then I don't have a power cable attached right here, so obviously you do need a power cable to get this guy to function, but we're still going to assemble it as is.
Yeah, this is going straight into another project where we're putting in L40S. We've got an H100 around here somewhere too. We've got, there you go. We're toying with the workstation cards in here as well, because some things are just a little more visual than just straight AI, so it just depends. With the 770, I guess the takeaway is not just the most open PowerEdge made, but maybe the most flexible too in terms of design and layout and what you can do with this thing.
Yeah, I mean, you have, even in our configuration where we might have 2 GPUs, we still have an open OCP slot and then 2 slots down below.
And 16 bays of storage and plenty of power. We didn't even hardly mention the Intel Xeon inside. I guess we probably
yes,
should. Hey,
Intel
by the way,
Xeon.
is Intel inside? Do.
Yes. There's a lot to like about this server, and it just comes down to, it's fun seeing how, like, I remember when the R740 came out, it's like, hey, it's one of the best platforms in the market, and seeing
Right.
how it's iterated over the past 7.5 years.
Iterated towards the point of openness, I think, is the big thing, without leaving behind the cool stuff that's made PowerEdge so special over the years, like BOSS, as that matured over time, like iDRAC, which has definitely matured, but as you said, is still the best platform management system out there for out-of-band management.
Yeah.
The adoption of new drives, new technologies there. I guess, too, the other thing this underscores is that the 770 is like your power hitter, switch hitter, 5-tool player in baseball. I know you're going to glaze over as I start using baseball references. It can do anything, and it's really capable. But they make a 670. If you want to look at like a software-defined node, that might be a better fit with those 16 SSDs if you want to pump that out over the line. If you
And it's
need
also available with E-cores.
E-cores, it's also available in an AMD version with the 7715, 7725. So Dell's got all these systems. I guess the hardest thing now is to choose what's the right PowerEdge for your needs.
Yeah, it is important when it comes down to selecting your configuration, because while you could make riser changes after the fact, you can't really change going from a single socket to a dual socket platform.
It's certainly not. It's harder
AMD
that way.
to Intel. You can't swap those components.
Right. But again, there's so many systems that are flexible. I hope we see an XA version of this too. I don't think that's something we've talked to them about, but the 760 XA, which is not this, but the version that would support way more GPUs, puts them in the front, puts them everywhere. That was pretty neat in the 760.
Yes, I don't want to hear that platform in the lab because those get a little bit spicy, but yeah.
Spicy and warm, which is why we've got this new in-row cooler, which we'll have to do another video on at some point,
Yes.
Especially this summer as we get cranked up. So I think the depth that we've put into this video on every little piece of nerdy PowerEdge thing there is one of our longest nerd videos, and we'll have to see how the audience receives this.
Yeah, it'll be exciting, and we can probably go deeper if someone needs it.
Oh gosh, you guys are sick. If you want that, ask questions in the YouTube comments. We're happy to get involved there. We also have a Discord if this kind of thing is fun for you. And if you want to be able to receive, what was it, our 730s you gave away?
Yeah, if we want 740s.
Now as we get to the 740, wherever that guy went, he's in the pile on the floor over there. That'll be maybe the next giveaway. We do those on Discord, but it's a great platform to interact and talk with our guys and extended team on everything we've got going on in the lab, tech support, job support, whatever else you could need. Check out the full review of the R770 on storagereview.com. We'll link to that in the comments. But until next time, thanks for tuning in. Hope you enjoyed this.